So now we are going through practice now 8. A particle moves in a straight line t seconds after passing a fixed point O. You get this part? T seconds after passing a fixed point O. Go and write down that when time equals to 0, the displacement is also equal to 0. You need all this essential information. You need to make sense of it. So it is from the question, t equals to 0, s equals to 0. This s refers to the displacement from O. Displacement from O. They tell us that its acceleration is given by 4t minus 16. Racy, are you able to see clearly? Or you need it bigger? I can't make it brighter. You can't see, let me know. Okay, so now they tell us that it passes O with a velocity of 30 centimeters per second. You need to be able to interpret this. Pass O with velocity 30 cm per second. That means when t equals to 0, what is the velocity? A textbook question. It passes O with a velocity of 30 cm per second. When t equals to 0, what is the velocity? 30. You need to understand this. Please do not ever have the impression that when time equals 0, velocity is equal to 0. It is not always the case. So in this case, t equals to 0, v equals to 30. So I like to list down all my information. T equals 0 and v equals to 30 cm per second. Find an expression for the velocity. So part 1, v, velocity is given by integrating our acceleration. Integrate, bracket 4t minus 16, close with respect to time. 2t squared minus 16t plus c. C is an arbitrary constant, but in this case, it is not that arbitrary because we know that when t equals to 0, velocity is supposed to be 30. Now we are going to have to find out the value of c to know exactly what the expression for velocity is. When t equals to 0, v equals to 30. You don't really need to do any working for this. You can tell straight away that c must be equals to 30. And now we have an accurate expression for velocity. Okay, without any ambiguity. Confirm, it's going to look like this. I know the velocity for all different time. Part 1 done. Part 2. Show that it comes to instantaneous rest when t equals to 3. So substitute when t equals to 3, velocity equals to 2 times of 3 squared minus 16 times of 3 plus 30. What are we hoping that this will give us? In part 2, we substitute t equals to 3. What are we hoping for the final answer to be? 0. They want us to show that it is at rest when t equals to 3. Therefore, when you substitute t equals to 3, you hope that you see equal to 0. If you get 0, it means that your previous part is correct. So 2 times of 9, 18, minus 48, plus 30, and we do get 0. Shown. When t equals to 3, velocity 0. Instantaneously at rest. Part 3. Find the displacement when t equals to 3. To find the displacement, we now need an expression for the displacement, which we don't have yet. So S is now integrating our velocity. Please integrate this and not the one with a plus c, because you don't know what the value of c is. You need to integrate our final expression for v. So 2t squared minus 16t plus 30 with respect to t. Okay, let's do it really quickly. 2 over 3t cubed minus 8t squared plus 30t plus, should I leave it as C?
C1.
Yeah, let's call it C1 because earlier on in the same question, I've already used C. Do you understand? So we don't want to confuse anybody. It is a different C from part 1. Oh, sorry, was that part 2? Part 1. See, part 1 you've already used C. So when in the same question you have another integration, please make the two C's different. So this is C1. How do I find out this value of C1? In order to find this value, I need a confirmed displacement with a confirmed time. In other words, I need a set of coordinates. When time goes 0, do you know the displacement? 0. That is a fixed, that is something that we already know. Why do we know that? From the question. When time goes 0, s is equal to 0. So we will need to substitute this in to find the value of C1. When time equals to 0, s equals to 0, we quote the relationship that we are using. And based on this, mentally, we can tell that C1 must also be 0. Okay? So now, s is given by 2 over 3t cubed minus 8t squared plus 30t. This expression will help us find the displacement for any single time. Please be very certain of the difference between displacement and distance. This is for displacement. I like to work with displacement because when I just substitute in the time, I get the answer as the displacement already. So when t equals to 3, our displacement will be 2 over 3 times of 27 minus 8 times of 9 plus 90. Anybody has the answer? So 36, but units, cm. Okay, part 3 done. Part 4. Find the total distance traveled by the particle in the first 3 seconds. So now, to find distance, you have to be very careful already. When they ask you to find distance, you must be very alert to know whether there is a turning point. Is there a point in the journey when velocity equals 0? Because when the velocity equals 0, either it stopped or it made a turn. In this case, when is the first time that v equals 0? 3, yes. From the okay, from part 2, we saw that when t equals to 3, velocity equals 0, right? But does that mean that there were no other times when velocity equals 0? It doesn't, right? It just tells us from part 2 that hey, when time goes to 3, it made an instantaneous stop. But we can't confirm before time goes to 3, was there another stop? So we have to find out first. And we do so by setting v equals to 0. Okay, let's do this. 2t squared minus 16t plus 30. 2t squared minus, what was it? Minus 16t plus 30. Plus 30 equals to 0. Okay, hang on. So Matthew, you did t minus 5 times t minus 3 equals to 0. So we have two timings when it is instantaneously at rest. Either 3 or 5. So is it safe to say that it did not make a U-turn from time equals to 0 all the way to just before 3? It didn't make a U-turn, right? Then what does that tell us about the distance? Same as displacement, no? Right? So when t equals to 3, your distance is also equals to 36 cm. Our displacement diagram will look like this. At time equals to 0, displacement equal to 0. So it continued traveling until this point, 36 cm. This is when time equals to 3. Then it made a U-turn. I don't know how far it traveled, but when 2 seconds later, it makes another U-turn. I don't know how far that is, so I'm not going to draw it. Part 5. Total distance traveled in the third second. In the third second. This tells us that I want distance from
t equals 3 minus t equals 2.
the distance between time equals to 2 and time equals to 3. So yes, you take the distance from time equals to 3 minus the distance from time equals to 2. So time equals to 3 was here, right? So time equals to 2 must be somewhere before that. So we need to find out what is this distance when time equals to 2. Then, whatever distance it is for time equals to 3, which is 36, minus whatever distance it is for time equals to 2, get the answer. That will be the distance traveled. So when t equals to 2, displacement will be 2/3. Somebody please help me calculate already after you substitute them in. 8 times 4 plus 60. 33 and 1/3. So this apparently is 33 and 1/3. Therefore, distance traveled equals to 36 minus 33 1/3, which is 2 and 2/3. Is that correct? Okay, that's it for our practice now 8. Then we've got our 3 homework questions. Okay, so let's write down whatever information that we can obtain from question 6 first. It travels in a straight line. Of course, it travels in a straight line. T seconds passing through a fixed point O. When they say T seconds after passing fixed point O, what are they trying to tell you?
Started behind the starting point.
Okay, it started before the point O, but they are trying to tell us over here that when t equals to 0, displacement equals to 0. This displacement over here is from O. Okay? The displacement from O is 0 when time equals to 0. As shown in the previous part, you will need this, especially when you have to integrate to find displacement equals to something, then you plus c, then you sub 0 into all the t's, and then you will find c. Now c is not always equal to 0, especially when we have trigo. When you have, what else can we have? E to the power of something. Okay, our exponential, yes. Then our c may not necessarily be equal to 0, as we will see later on in subsequent questions. They also tell us that velocity is given by 2t squared plus 1 minus 10k t plus 18k minus 1. Looks very scary. Velocity, as shown, out of all these over here, what is a variable? That means something that we allow to keep changing. T is the time, right? What is a constant? K is a constant. It is supposed to be a fixed number, which we will have to find out what it is. If we manage to find out what K is, then it becomes just a coefficient. Okay? Find an expression for the acceleration. Part 1. A for acceleration, dv over dt. For t plus 1 minus 10k. Straightforward. Now in part 2, they tell us that when t equals to 5, a is equal to 1. When t equals to 5, a equals to 1. This is from the question. What shall we do with this? Sub. We sub inside a to become 1. A to become 1 and t goes to 5, and then we are left with one equation with how many unknowns?
One unknown.
Just one unknown. I'm sure we can do that. So substituting, we have 1 equals to 4 times of 5 plus 1 minus 10k.
K equals to 2.
Okay, thank you. K equals to 2. And part 3, using the value of...
Understand what it means, the part 3 question.
Okay, hang on. Using the value of k, which is 2, find the range of t for which it is moving in a positive direction. That's the key part to this question. When v equals to 0, no, greater than 0, then we have 2t squared, 1 minus 20 is negative 19. Um, 36 minus 1, 35. This must be greater than 0. So for this, we need to factorize. So 2t minus 5, t minus 7, greater than 0. Okay, this is a quadratic inequality. So in order to solve the quadratic inequality, I need to draw my graph. It intersects at 2 points, 5 over 2 and 7. We need the portion that is greater than 0, so we have 2 regions right now. If this is purely an inequality, quadratic inequality question, our answer will be t less than 5 over 2 or t greater than 7. However, there is a context to this. T refers to time. Can I have time being infinitely less than 5 over 2? What is the minimum value for time? So it has to be this way. Okay? Notice that I did not include equal to 0 because when time equals to 0, our velocity is, did we find out? 0. We should, because when time equals to 0, if we substitute when t equals to 0, our velocity is 2 times of 0 squared plus 1 minus 20 is negative 19 times 0 plus 36 minus 1, which is 35, which is greater than 0. So when time equals 0, it is still moving in a positive direction. So I need to include this equal over here. Because when time equals 0, I substituted in, I found that the velocity, the initial velocity is 35. Our velocity now has to be equal to 0. When v equals to 0, our time equals to 5 over 2 or 7. We found that earlier on already. Expression for displacement. Yep, integrate our velocity. Two t squared 19t plus 35 dt. And we also know that when t equals to 0, s equals to 0. So this is our expression for our displacement now. Okay, they also tell us that t seconds after passing O. The t seconds after passing O implies that when t equals 0, s equals to 0. Okay, you must have this. Find the value when it first comes to instantaneous rest. So why do you need help for this? Velocity equals to 0. Then this is a trigo equation that you have to solve. Cosine something is negative. Which quadrant? Quadrant 2, quadrant 3. Okay, we also know that the range for t is from 0 to 2 pi. What about? I will not answer that question. What about the range for t over 2? What is the range for t over 2? You divide by 2 throughout. 0 to pi. Okay, so it is found in quadrant 2, quadrant 3. I can tell that t over 2 is now going to be in quadrant 2, there will be pi minus cosine inverse half. That's going to be my first answer. Do you agree? This is the answer, this is the angle in quadrant 2. Now the angle in quadrant 3 is, what is it going to be? If quadrant 2 looks like this, this is cosine inverse half. Pi minus cosine inverse half. What about in quadrant 3? It will be pi plus. Sorry. This over here is our cosine inverse half. So in quadrant 3, our angle will be pi plus cosine inverse half. These are our two angles. Any questions so far? Use this chance to recap your trigo. Yes? How do you know at this point? Wait, you have a valid point. How do you know? He is saying that we should reject this. My question to him is, how do you know? Before you calculate. There is an answer to that. So how do you know? Exactly. Exactly. Here, we already found that the range for t over 2, the range for t over 2 is from 0 to pi, right? Anything beyond pi, we have to reject. If I'm talking about the third quadrant, I'm already taking pi plus something. So he is saying, don't bother. Okay? Good idea. Let's reject this. So now we only have one answer. Cosine inverse half is pi over 3. So pi minus pi over 3, resulting in 2 pi over 3. This is our t over 2. But they want the time. If t over 2 is equal to 2 pi over 3, then time must be 4 pi over 3. And units, seconds. Next, part 2. The total distance traveled by p from 0 to time equals to 2 pi. Okay? We want distance. So when it is distance, you have to be alert again. Is there a turning point from between time equals to 0 to time equals to 2 pi? Was there a turning point? Was there a point when velocity equals to 0? Yes, what time was that? 4 pi over 3. At this time, it made a U-turn. Do I need to consider the next timing? No need. Because it is already beyond 2 pi. Because this is the value for pi, t over 2, right? This is the value for t over 2. If I were to go and find out what t is, it is going to become 2 pi plus 2 cosine negative inverse half. Then this is already more than 2 pi, which is outside of the range. Don't bother. So we have rejected it, we continue to reject it. Now this is the turning point. In order to find total distance traveled, we need displacement when time equals to 0. When time equals to 0, displacement equal to something. I need this information. I also require when time equals to 4 pi over 3, s equals to something. And finally, when time equals to 2 pi, what is the displacement? I need all these in order for me to draw my graph. Okay, so let's start. When time equals to 0, do I have an expression for the displacement? Not yet. So I need to find out. Okay, so given that v is equals to 2 cosine t over 2 plus 1, s will now be 2 sine t over 2 divided by half plus t plus c. Integration. So this is 4 sine t over 2 plus t plus c. In the question, they say that when t seconds after passing O. So early on, when we started this question, we already said that when t is 0, s is 0. Substitute it. When t equals to 0, s equals to 0. Okay. 0 is 4 sine 0 over 2 plus 0 plus c. Sine of 0 is 0. C equals to 0. So my expression for s, the displacement is 4 sine t over 2 plus t. So we have already answered the first one. S is 0. Next, when t is 4 pi over 3. Okay, so we divide by 2, then we plus another 4 pi over 3. This gives us two root 3 plus 4 pi over 3. 2 root 3 plus 4 pi over 3. Leave it as exact as you can first. Next, when it is equal to 2 pi, our displacement is 4 sine of 2 pi over 2 plus 2 pi, which is 2 pi. Now we are ready to sketch. We always use the displacement axis. We start at 0. Time equals to 0. Displacement is 0. When time is 4 pi over 3, our displacement is 2 root 3 plus 4 pi over 3. Then it made a U-turn. If you use your calculator, this value is approximately 7.653. Okay, 28. Okay, the reason I'm writing down is because I want to ensure later when I substitute 2 pi, it will be less than this value. So that everything makes sense. Okay, and indeed it is true. When t is equal to 2 pi, this value is 2 pi. Approximately 6.28, which is less than 7 point something. From here, calculate total distance. And you get the answer, round it off. Done. velocity 4e power t minus 5e1 minus 2t. After leaving a fixed point A, when t equals to 0, s equals to 0. This is the displacement from A. When it is instantaneously at rest, when v equals to 0, 4e power t equals to 5e power 1 minus 2t. A few different methods of doing this. I'm going to group all the e terms together. So e power t divided by e1 minus 2t is 5 over 4. On the left hand side, since they have the same base, I can combine the powers. E power t minus 1 minus 2t is 5 over 4. The objective is to have just one e appearing so that I can ln. So e power t plus 2t, 3t, minus 1 is 5 over 4. Taking ln on both sides, 3t minus 1 is ln 5 over 4. 3t, 1 plus ln 5 over 4, t is 1/3, 1 plus ln 5 over 4. So this is the time. Let's calculate. So 0.407715. Okay, so this is the time when it is first at rest, round it off, 0.408 seconds. Distance traveled in a second. So distance traveled from t equals to 1 to t equals to 2. The second starts from t equals to 1. Because the first second is from t equals to 0. Second must be from t equals to 1. Okay, so now I need the expression for our displacement. So since v is 4et minus s, our displacement is 4e power t, nothing changes. You differentiate this, you integrate this, you get the same thing again. Okay, so minus 5e1 minus 2t divided by, differentiate the power, which is negative 2. Sorry, very lazy. Okay. Alright, to show the integration, then we have to plus c. 4e power t plus 5 over 2. When t equals to 0, s equals to 0. Okay, this is where we have a case when c is no longer going to be 0. Substitute in. 0 for e power 0, which does not give us 0, plus 5 over 2 e power 1 plus c. Okay, power 1 don't need to write. So based on this, c is negative 4 minus 5 over 2e. Our expression for displacement is now c is negative 4 minus 5 over 2e. It has to make sense that whatever our c value is actually a number. It is a constant. But I will leave it as this so that it is the most exact figure. When time equals to 1, for the second, s 4e plus 5 over 2e, 1 minus 2 is negative 1, minus 4 minus 5 over 2e. This gives me a certain value. Go and calculate yourself. When t equals to 2, 1 minus 4 is negative 3. No, actually I don't have to round off, because I want to subtract. So distance traveled equals to whatever we have over here okay? Whatever your answer is for the time equals to 2, minus away whatever your answer is for time equals to 1. And you get the answer, then round it off. Average speed for the first 3 seconds. What do we need for average speed? Total distance, not displacement, right? We need total distance again. So when you need distance, you have to be alert. We need to check whether there is any turning point between 0 and 3. So is there any? Was there a time when the velocity equals to 0? Part 1, yeah. What was the value? This is the timing. No, let's use the exact one. This is the timing when velocity equals to 0, and it is approximately 408 seconds. So that was a U-turn over there. Therefore, to find the total distance, we need time equals to 0, s equals to something. Time equals to 1/3, 1 plus ln 5/4. We need the displacement. And finally, when time equals to 3, we need the displacement. Go and draw it out. Okay? Let's continue. When time equals to 0, our displacement is zero. When time equals to 0, displacement was 0. Okay. First one done. For the second one, when time equals to 1/3, blah blah blah, s over here is equal to, go and substitute and calculate. This value is negative 1.775, approximately. Okay, approximately. And finally, when time equals, wrong one. The one on top, when time equals to the 1/3 ln, our displacement is negative 1.775 to 4SF, approximately. And when time equals to 3, our displacement was approximately 69.56. Now we need to make sense of this. Okay? Our displacement line again. Starting from 0, when time equals to 0, it is found here. Now time is going to increase. The next timing is 1/3, blah blah blah. What is the displacement? It is a negative value. Where on our axis should we place this negative 1.775? Left side. Over here. Negative 1.775. And this time over here is approximately 4.08 seconds. The exact value is over here. 0.48 seconds. 0.8 seconds. So it traveled this way. Then it made a U-turn. By the 3rd second, it ended up over here, 69.56. So I can find the total distance now. Total distance is 1.775 times 2 for these two portions plus 69.56. Average speed equals to total distance over total time. Do your substitution and you will get approximately 24.4 meters per second.